All right, well, welcome everyone to another PSL Demo Day. Today we're pleased to have Max Ghenis, who is founder and president of the UBI Center. Max is also a contributor to a number of models in the PSL library, including microdf, which he maintains and which he'll demonstrate today. Max, please.
Thanks, Jason. And thanks for joining, everyone. So yeah, I'm working on a couple of projects for PSL. One is maintaining the microdf package, which I'll go through, as well as the SCF package, which is an incubating project with PSL, but it still provides some useful functionality for querying the survey of consumer finances. So I'll talk about both of those today in combination with a product that I use a lot, which is called Google Colab. And that lets you do data analysis in the cloud, no installation needed, just in the browser. So with that, I will present my screen. I'll start just with a brief overview of each of these components. By the way, Jason, I can't see the chat, so if anyone has things, please just let me know.
I will.
So yeah, the SCF package is the first thing we'll use. And for those who aren't familiar, the Survey of Consumer Finances, it's a survey that the Fed administers every 3 years. And it's sort of the source of truth for US household wealth data. It has publicly available, very rich microdata that spans back since 1989. So you can actually do a lot of longitudinal, well, it's point in time, it's not a panel data set, but yeah, so, and then you can also load it with the SCF package. It's a very simple function. It just has 2 arguments. One is the year or years that you want to query, and the second is the columns you want to get. So it returns a data frame with all that data stitched together if you want multiple years. The microdf package has a lot more functions. One of them is not a function, that's just sort of the paradigm. But basically the way it works is it helps you analyze survey microdata, a very common type of data set that people use in economics is where each record represents a variable number of rows, because usually the sampling method just justifies giving people different weights because not everyone is sampled, not every type of person is sampled at the same frequency. So basically the paradigm for microdf functions is that you pass the data frame, you pass a string with the column or columns to summarize, and the weight column, and you can also group by different columns as well. So we'll go through each of these pieces of the paradigm with several different kinds of functions that are in microdf. Google Colab is a tool that's actually short for collaboratory, and it lets you do Python data analysis in the web. So it's built on Jupyter Notebook, which is really the canonical tool for doing data analysis in a notebook kind of format where you have the coding and maybe some text, maybe some images, and it shows the results right in line, as well as visualizations. So it's kind of nice because you don't have to install anything at all. It just runs on Google servers, and you just open it in a web browser. It comes with a lot of packages installed, but you can also install other packages, and we'll use that functionality to install the SCF and microdf packages. There's also some nice stuff, which I don't think we'll get to today, but you can actually do real-time collaboration, and you can have comments, sort of like Google Docs or Google Sheets, and it does all the automatic saving. It saves it in Google Drive, so along with all of your other Google Drive documents. So with that, I will move to our notebook, and actually I'll drop this in the chat too. So we can, let's see if anyone wants to follow along. So you can kind of see while this is loading, this is just a URL that goes to a unique notebook the way any other kind of Drive document would. So right now it's not connected. You have to do this connect thing, but basically you can have Markdown cells. So this is like a text cell, they often call it. So you can enter any Markdown you want here, just like a Jupyter notebook. And once you say, okay, here's some more text, just do Control Enter, Shift Enter, and it sort of updates the cell. So you can kind of describe everything you're doing with these this rich text editing functionality. And we can do some basic Python without installing anything. So if we want to just do some arithmetic, we can do that. And you can either click this or do various keyboard shortcuts to get the result you want. We'll also be using lists. So if you're new to Python, this is a very common kind of piece of the language is lists. So we'll use this to, for example, get multiple, you can get for multiple years, multiple columns. You can put strings in here or numbers, anything like that. So we're now connected to the environment, which means that we can install and load the SCF and microdf packages. I'm actually going to type everything out except this part because it's kind of annoying, and I often just copy it from somewhere else. But basically, this is the command you use to install these packages. And I wouldn't necessarily try to memorize this, but basically what it's doing is it's running this pip command, which installs Python packages in a terminal. And by using the exclamation point, it's saying do that inside the terminal rather than in Python. And then you can actually install any Python package on GitHub using this git plus and then the URL on GitHub for the repository. So these are both on the PSL models repo organization, excuse me, and then .git at the end. So we're just going to do this. This just takes a second. And while that's loading, we can start to actually import these. So in Python, the keywords for importing are just import. And you can actually add aliases too. So I often alias the microdf package as MDF. So that shortens the commands later on. So the first thing we can do, and let's just load the 2019 net worth data with the SCF package. And to see what column that is, I listed the codebook here. That's also, I think, listed in the SCF package documentation. But this is hosted on Berkeley's website. And here we've got net worth is the categorization. As you can see, there's tons of columns in the SCF, so it's a very valuable data set. If we scroll down to this net worth section, we have net worth here. And this is probably the most used single column in the SCF data set. So we can just grab this net worth. And scf.load is a function. So also nice, I kind of skipped over that, but it does tab auto completion. So, and now it also shows you the documentation for the functions you're using. So here we know that there are two arguments in the load function. The first is the years, and you actually don't need to pass the years. If you want all years, you can just leave that empty. And then the columns is going to be a list of column names. So we're going to pass 2019 as the year that we want, and this, it's actually lowercase in the data set. But so now we can do this, and let's actually save this as wealth 2019. So what this is doing now is it's actually querying the Fed Reserve servers where the data set is hosted, and it's turning that into a data frame. So let's take a look. We can add a new code cell. I sort of did that with my keyboard, but wealth 2019. And this has the net worth column as we requested. Also, the SCF package always returns the weight column because this is such a critical column for doing any kind of analysis. So basically the way you can read this is there's some household that was part of the survey. They have about 2.1 million in net worth. And the way that that person was sampled relative to the rest of the population in the survey is they represent about 6,000 people in the US, 6,000 households. So this person also 2.1 million, but they represent fewer people. So that kind of person was sampled a little bit more in the survey. Cool. So what we can do is now we've got this data set, and this is exactly the kind of data set that the microdf package really uses for all of its analysis. So for example, if we want the mean net worth, we can do MDF, that's the alias for microdf. And we've got a bunch of different functions here. We can start to type it in. A bunch of them are weighted. So weighted underscore mean, for example, is the one we're looking for. And here again is our documentation. So we've got the data frame name. That's going to be wealth 2019. The column we want is net worth. And the weight is going to be WGT. That's the weight column in the SCF package or SCF dataset. So there we go. About 750K is the average household wealth in 2019. And since these all share the same paradigm of we've got the MDF, we've got the data frame, we've got the column and the weight, if we want the median, we can literally just change this from mean to median. So here the median is about 122K. So wealth is kind of right skewed in the US. We can also, while we're at it, let's let's just move on to here. And let's grab the total net worth and see what that does. So you might guess that this would be weighted sum, and you would be correct. So here, that's a really big number. Let's divide it by 1 trillion. So 1 times 10 to the 12th is trillion. So 96 trillion total wealth in 2019. This is actually a bit lower than what you would get from more administrative high-level data sources. So the Fed publishes via FRED the total net worth for each quarter. And here it's more like 110 trillion or so. So the SCF is missing some data. It's missing some at the very top end, for example. It's also missing some in terms of adult dependents. People living with their parents might not have all of their wealth counted appropriately. So there are some caveats when using this data set, but it's quite rich. So just to see what I was talking about there, we can actually grab the wealth 2019. If we want to see the maximum wealth here, you can do .net worth .max. So this is going to take the maximum net worth in the wealth 2019 data set. And that's pretty big too. So let's divide that by 1 billion. Yeah, so the richest person in the data set only has about 2 billion in wealth. So that's going to miss some of the top end. So a lot of people often supplement the SCF data with, for example, the Forbes 400, which has the 400 wealthiest people. That's not something we have yet, but it's something we're looking at. Okay, before we move on, we're actually going to do some trends over time. Let's just take a look at the Genie Index. So Genie Index is a measure of inequality. It goes from 0, which is perfect equality. Everyone has exactly the same amount of income or wealth or whatever you're measuring, compared to 1, where just a single person has the entirety of it. So instead of weighted sum, we're going to do Genie. So the current Genie Index is 0.85. This is a fair amount more unequal than the income distribution, for example, which kind of makes sense since it's accrued. Okay, so the second half of this demo, we're going to actually look at this over time. And to do that, we're going to basically just drop the 2019 argument from the load function in the SCF package. And then we can use the group by argument in microdf functions to see how things have changed over time. Okay, so we can basically copy this. It's, again, the SCF load function. And let's just call this wealth. And now, since we're doing, we actually have to specify columns equals. So this is the second argument in the function. This will take some time. It takes, I think, maybe a minute or so. So while that's running, we can start to see what we're going to do next. So the goal is we're going to calculate the Genie Index by year. So if we compare this, for example, everything we were doing here, we were skipping the last argument. And we can actually, I think this will still autocomplete. I guess it doesn't autocomplete, but we can have a group by argument. And here we're going to specify year, so basically looking ahead, we're actually this wealth data set, because we specified more than 1 year, it's actually going to return the year in the data frame as well. So we kind of get 2 columns for free. We've got the net worth, which we specified. We're also going to have the weight column, and we're going to have the year. So if we take a look at wealth, net worth, weight, and year. And
Max,
it goes
there's
from
a
1989
question in the chat. So Rick was asking, how do you deal with inflation? So here now you're pulling across multiple years. Is there any easy way to adjust for inflation?
There is a deflator in the data set that you can pull out. That's definitely a feature that I want to add to the SCF package. For inequality, if you're just looking year by year, it's not a factor. But yeah, I think that would be a great new feature to add. Great. So we can take a look here. And we can look at the Genie Index by year. So we just added the group by equals year here. And now we see the Genie Index for every year. So it looks like it's been increasing since 1989. It actually turned around a little bit in 2019. So let's save that as a new object. So Genie, let's call it Genies. And this is kind of cool. Because Pandas interacts really well with plotting. Pandas is basically what's returned. It's the package where doing this returns a Pandas series. You can also have different things that return Pandas data frames, which are like Excel spreadsheets kind of for Python. And it works really well with plotting. So you can actually just do genies.plot. It's not the most beautiful visualization on the planet, but you can see very clearly what the trend is very easily. And it's got the year here and the Genie Index here. Cool. So there are actually a number of inequality functions in the the microdf package. So let's do, for example, mdf.share or top 1% share. And this is going to be the exact same kind of paradigm. So we've got wealth. Net worth is the thing we're summarizing. WGT is the weight, and the group by is going to be year. So here's the raw data, and we can again just call plot here. So we don't actually need to save it to a new object. We can just plot it directly. So pretty similar. It looks like there was some spike here, but basically it's been increasing over time and also kind of fell a little bit in this past year. Another one that's kind of common in the wealth or inequality literature is comparing the share held by the top 10% to the share held by the bottom 50%. And this tends to have more extreme sort of directionality because as inequality, if the top 10% share increases in general, that has to come from somewhere. So the bottom 50% might fall as well. So you've got the numerator increasing, denominator decreasing. But basically, here we can do that as well. And that function is T10B50. So pretty similar. It looks like it actually peaked in 2013 and then fell in 2016 and 2019, but it's been increasing over time as well. And the very last thing I'm going to show is just how to do some interactive graphics. So you can use Plotly. Plotly is what we use a lot at UBI Center to do our interactive graphics. So this requires importing a new package, Plotly Express, and the convention is called that PX. And let's actually just save this guy. We're going to save this as a new thing because it'll make it easier to plot. So T10B50, let's call that this. And now let's just remind ourselves what this looks like. So we've got the basically the index is the year here, and then these are the values. So what we can do is Plotly Express has a different kind of interface than Pandas and Matplotlib, but we can do px.line, and the data frame is going to be T10b50, and it's a little kind of awkward, but basically we have to make the x is going to be T10b50.index. So this, we can be explicit here, and then we have to specify the y as well. So the y is actually just going to be T10b50 because it's really just the values there. And here you can see it's also the chart, but now you hover over and you get some interactive hover cards. So it's kind of cool. So basically, latest is 2019, where that ratio from the top 10% wealth share to the bottom 50% is 51. Great, so that's the end of the demo. I just want to go back and share a little bit about, and kind of talked a little bit about this, but some of the next steps for this package. And you can always go to the PSL GitHub repositories for SCF and microdf to see what we're doing, so you can actually watch those repos and be notified of changes or new releases. But for the SCF package, I think augmenting the data with Forbes 400, that's a very common thing to do in the literature, so definitely want to make that possible. This adult dependence issue I mentioned, I think there are some ways to adjust for it, and then it goes from being just a tool into a model, and that's more consistent with the rest of the PSL community. For example, previous of these demo days showed TaxBrain, OGUSA, those are real models, and I think there's opportunity to make the SCF also kind of a model of what we think the real wealth situation is, not just from this specific data set, but from multiple data sets. And similarly, I think interpolating and extrapolating the data. So every quarter, the Fed Reserve publishes the aggregate wealth statistics as well as some breakdowns. So there could be a way to basically age the SCF microdata to match those estimates. Inflation adjust, so per Rick's question, I think that would be really cool. And of course, add it to the PSL catalog since it's currently just in incubating status. On the microdf side, we didn't really get a chance to go through it, but there are some visualizations in microdf. So growing that library would be cool too. There's a lot of really great work that people have done to innovate on how to visualize these micro level data sets, especially comparing a baseline to a reform. So looking at policy reforms and how people respond to those. Yeah, I'd like to do more with that. Also, the interface, right now it's a little bit clunky because you have to specify the weight column every time you do your calculation. So there could be some ways to basically make that more streamlined. Also documentation, didn't talk about that today, but there's some documentation on JupyterBook that could be enhanced. And finally, figuring out how to really interact with TaxCalc. So Tax Calculator is the microsimulation model that PSL uses, and microdf does actually have some functions to work with that specifically. So figuring out how to work with TaxCalc compared to TaxBrain, which is another Python package. So not things we necessarily described today, but things that are on the radar. With that, I'll take any more questions if there are.
Max, I have a question about the augmentation of the SCF with the Forbes 400. I guess first part of that question is there like a standard process by which this is done? Are you following someone's lead on this, or is this kind of you're like inventing something new here? And then second part of that is it very difficult? Like you said, the SCF is very rich, it has a lot of detail, although that net worth number is very important. You know, that detail is also important for many studies. And can you infer that level of detail from the Forbes 400 list?
Yeah, I think what I've seen is that people just use it for basically total net worth. just the distribution of net worth. I don't know if it's been used or if people try to impute other features from the Forbes 400. I think we can learn a lot because, for example, Penn Wharton budget model, they've used it for their wealth tax analyses. So I think there's some literature, but we haven't fully researched it yet.
Okay. Well, that sounds good. I'm looking
I got
forward
a
to that.
question for Max about microdf. So you've got the SCF package, and then you've got microdf is this general purpose way to manipulate and interface with these micro simulation or micro data sets. Is the strategy here for, say, another prominent data set like the PSID, for somebody to create a PSID Python package that does what you've done for the SCF, but does that for PSID? And then how, I'm thinking about the interface with microdf, then would microdf just have to be adjusted so that it can handle whatever format the PSID data comes from? I'm just trying to think of how this, I really like these two tools, and I want to know how they would expand across the broader universe of data sets that we care about.
Yeah, PSID is a different kind of data set because it's panel. So I think it would take a little bit more thought. I'd love to figure out how we could do that. I guess you could, I mean, just for any individual year, you could apply the same kind of microdf functionality. But yeah, I agree with the vision of having little packages that address specific data sets, and then some packages that apply general purpose kind of analysis and also visualization, either within that same library or separate libraries. Yeah, I think that's the right direction to go. I think it would take a little more thought to work on the PSID specifically.
Am I right, though, that you're envisioning microdf as a package that would go across data sets and be used multi-purpose?
Yeah, I mean, I created it actually to make it easier to work with the taxcalc package, which produces its own kind of data set through either the PUF or the CPS, and both of those are augmented data sets through the tax data project. But as you saw, works well with the SCF. I use it a lot for the CPS ASEC, just the raw March supplement. So yeah, I think it would be ideal to make it work with as many different data sets as possible.
Yeah, just to follow up on those comments. Yeah, I think it's nice you've built this off Pandas, so you have like a strong foundation there. But I think those tools, like making it easy to do the weighted computations, is really important for those of us who deal with survey data and not something that's, you know, easily done in native Pandas packages or in the native Pandas. So it's, I think, a really useful innovation.
Yeah. Thanks.
All right, any other questions here? Well, Max, thanks so much. Enjoyed it.
Yeah, thank you, everyone.
Take care.